Alright, continuing with a second part to this response videos of sorts to a proposal by Franklin Hu, and regarding a critique of the electromagnetic field being real stuff, a field of magneticness and a field of electricalness having perpendicular orientation to each other somehow, and somehow conveying light through some sort of process of agitation in these two fields as a reasonable theory of what a photon is. And I agree with that basic point that that answer isn't good enough. It's not even in the ballpark. Not not in the same city as the ballpark. Not trying to get the right position here. Just not viable. It's just an imagined fetus. It's not even a fetus. So anyway, but the rest of his argument is sort of not very, in my opinion, useful in the sense that it's ether-based. Another, I think, non-starter, doesn't go anywhere. Can't compress it into matter. You can't do, this doesn't make any sense. Diagonal problems, all kinds of problems with ether. So why bother with it? So these conversations with other people with imaginations and reasoning skills to say, the current answers are just silly. They're just fables, just religions, little God stories, whatever, David and Goliath thingies, or three pigs, whatever you want to, it's just made up stuff. And people with imagination are saying, I can't even imagine it. So clearly, it's just, the only people who can buy it are people who don't have an imagination. Because if you have an imagination, you're saying, I can't imagine this. I can imagine lots of crazy stuff, but I can't imagine this. So how can this be right? And so then they apply their imagination to saying, what's the right answer? How do you fit all these little bits of evidence together? And that's sort of the problem here. Is this: we're all fitting the evidence from different locations, different perspectives, different volumes of knowledge and information, specialties, how we want to look at it, and and there's just no way to have a ordered conversation about what you can agree on and what you can't, and what the consequences of that are. And it's almost like the real difficult part is most of the disagreement, or substantial part of disagreement, lies in this elemental stuff: wave-particle duality, entanglement, waves, period, versus particles, notions of charge and energy, the basic functions, elemental functions. And we don't agree on mechanisms for the elemental bits. So conversations about the more complex stuff just doesn't really matter. The emergent stuff doesn't really matter. I mean, the fact that waves can't be elemental, can't even agree on that. Some people think it's somehow you start with something, a nothing waving, and that creates a universe somehow. Well, anyway, so it's a problem. The conversation is difficult, and our personality conflicts don't make it any easier, and it's just bad. It's just unfortunate that there can't be a better, more mature way to dissect out of all this knowledge that we do have, all this experimental evidence, some sort of real, substantial, well verified theory. Just doesn't happen. So anyway, I don't need to stop the recording. Don't hit that button, Gary. Go to the video. Hit the play button.
Circular polarization. It's really fancy, but it's not. So. Okay, so now that I've explained what circular polarization is, we really need to discuss what's my next point here. which is okay. The next point is, how can light travel as a ray? Okay, like I said, I've got my pencil here. I'm claiming that light really travels like this, okay? And
yes, well, your picture's very small, and it probably isn't on my video. He's just holding a pencil and saying it travels like this. And yes, like I said, it's you sort of do that. You can imagine it that way. I imagined it that way originally, that the wavelength was the length of a something, that photons had a length to them, because the word just says it, right? Wavelength. It's sort of saying to you this thing is a thing. And then you're saying, but no, you can make a frequency just by putting a gap between things. And so the gap between them can be the thing that's variable. The length of the thing doesn't have to be the thing. The variability of the gap can be the thing. So you have to have a gap between them. See, that's the, when you start thinking about it, photon doesn't make any sense if you start sticking pencils together and you don't have a gap between them. Then they're just one pencil, you know. And then how do you break that into pieces, you know? So that doesn't work very well. You certainly can't quantize it then, because the pencils end up being run-on pencils. You know, you lose any, the frequency doesn't mean anything. If they're head to toe, head to toe, head to toe, you lose the frequency when something's trying to detect it. So that was where I started saying, well, how can something detect the difference between one and the other, you know, if you don't have a gap? And as soon as you create a gap, then you say, well, why don't I just make the gap the wavelength? Problem solved.
And that way I can resort to explain how these things work without any transverse anything. I mean, a lot of people in the dissident community like to contend that, oh yeah, there's...
Yeah, it's like it needs to be two fields it's moving through instead of just one field. So it's just kind of, again, it's kind of obvious that you don't need the two fields. It's kind of obvious that Maxwell's equations had two constants put into them that basically combined equal the speed of light. So it's sort of saying, kind of overtly, this was an incomplete or a unnecessarily bisected theory of the function, and you don't need to bisect it because it's really just one force moving the speed of light. There is no force moving half the speed of light and another force moving half the speed of light. So, you know, it sort of tells you the answer right there, that the two-field theory is completely, it's just losing points. You know, it just isn't a viable option to make it that much more complicated. It's bad enough trying to explain it as one field. I think you're dead in the water doing it with an ether or field. This isn't a field perturbation. Photons are a thing. They travel through empty space.
It's an ether, but it must be solid because that's the only way it can transmit a transverse wave, right? No, I think that's completely wrong. I've just shown that you don't need to have any transverse component at all in order to have polarization happen. It just needs to travel like a pencil, right? So how do we do that? So it would be, if you were to say that electromagnetic waves are exactly the same thing as, say, a sound wave, you would have to say that they would have to travel in basically a non-radiating fashion, right? So if we take your standard speaker or sound, we know that radiates out in a spherical pattern. And you really can't create, say, a beam of sound like you would with a laser. Although I heard there are some experiments in the military trying to do stuff like that. But generally speaking, it's not really possible. The sound wave generally likes to radiate out, and you can't create a laser beam of sound. Although that is exactly what we need. We need like a laser beam of sound. We would.
Yeah. Well, yeah. I can't really speculate on the fact that you can't do something when, yes, I think there can be sound that's directed because you perturbate molecules in exclusively one direction, and so you could theoretically get some of that out of it. But obviously the point is the reason why these mediums work is because there's adhesion between the molecules. They drag each other along. They're thick mediums. And drag would be a key concept where you don't see any results of that in the universe. So if there was this ether that was perturbating light, it would have to have connected to it an awful lot of something called drag, because it would have to have adhesion to create circular, it has to create the friction somehow, the difference in the speed, the difference in the momentum, and you can only have that by dragging stuff that doesn't want to come along, accelerating extra baggage. That's what creates those arced lines.
Need to have a speaker which only shot sound straight forward and only caused the molecules directly in front of the speaker to go back and forth and leave all the other molecules not in the beam low, right? So they wouldn't spread out.
I don't think they go back and forth, but that's not terribly important. They're shot in one direction at the necessary speed. They're not shot in both directions in the necessary speed, so they're not push-pulling. Sound isn't push-pull. Sound is has momentum in a direction. It doesn't just stay here going push-pull. So I think you're wrong to think it's push-pulling. The rebound speed of the speaker is much slower than the speed of the forward jolt.
So, and if you weren't directly in front of the speaker, you should hear nothing, right? Absolutely nothing. You'd be going full bore, and you would not hear anything because all the sound waves would only be moving straight forward, which is what we need. So we need like a sonic laser. That's what we want.
Right, and the only thing that gets in the way is the ether. Obviously, I'm just saying because clearly the fact that the molecules have a little pull on each other, they have to, again, they're connected like water molecules. They have adhesion. That's why you have waves, is because you have adhesion between the molecules. They want to stay connected to each other, and so they have to drag each other to the party.
And actually, and if you were to observe the wave packet that's coming from this sonic laser, you would see that it has a fixed length, and it would be the same shape as the original speaker, round, and you would see that it literally travels as a rod. So there would be compression waves in here.
So it literally travels as a rod. I think it's just nonsense. There are obviously atoms banging into each other, so all they're doing is two atoms get close. Those two atoms, split. One bangs into the other, transfers the momentum to the other. So for a moment they're compressed. This one pops off like a kinetic ball. It hits another one. For a moment they're compressed. For a moment, and so it just thickens the amount of stuff in an area. And that's all water waves are illustrating. There's more water here, and because the water separated here, there's less water here. And then there's more water, and then there's less water, and there's more water.
But it would be just like this pencil. I mean, if you could color it a different color, you could literally see.
And you got to see, all these things are so subtly different. You got to recognize that the reason why water makes it so obvious, bulging, is because it's uncompressible. So, so you can't push the molecules any closer together. So all you can do is bang into them, and they'll push each other based on their deformation. But they're always going to spring back. So they just say, I'm not going to stay compressed. You can't compress me. Where air molecules can be compressed. So the two mediums are fundamentally different in that respect. This has got to be understood. That's why the speed of sound is different in the two mediums, and why one medium doesn't carry frequencies very well. I mean, it doesn't. It hurts them. Water does quite a bit of distorting because the water has all kinds of noise in it.
See it pass through the medium like a particle. You would see it would just be just like this pencil, right? So
see, water is more like other molecular substances where you have to think that when a photon goes in and no energy is released, like no infrared radiation, no other stuff gets out, it means that energy is still inside. It means it's still bouncing around in there forever, theoretically. I mean, if it doesn't come out, it stays in. It makes it, it's got noise in it now. It's got something, that bit of energy, or vibration, if you want to call it that ability to compress things, just keeps compressing them. So water has a very high ability to not let stuff out, internal reflections. So the noise stays inside the water, and it just keeps going all over the damn place. So there's lots of noise in water, and that noise means is the molecule you're going to push this way, it's going to get pushed this way by something else, and so the energy is going to get blended in to all the other energy. It's very much more dispersive.
That would seem to be a pretty tall order to have a way to do that, right? But I think this is exactly what we need to think of as EM wave. using basically the same physical mechanisms as sound waves. So the idea being that this is going to be like a light wave packet, just like the pencil. It might contain individual waves in here.
It might contain individual waves. So now he's not making any sense at all. Now he's turning a single photon into individual waves. Was that? I thought this was the wave. This was the wavelength. The pencil. What are you doing? I mean, literally. This is like this is like a 500 megahertz radio wave. It's this long. The distance between the bits, I would say. This at the speed of light. That's how long it takes a bit to get there. At the speed of light.
That would say determine its frequency. But generally speaking, it has a finite width, right? It's very narrow, so it can fit through very narrow spaces. It has a length, and can be isolated as traveling through space. They have done experiments like this with these ultra high-speed cameras, and they've actually.
They're not ultra high-speed cameras. It's all such a fake. They take a picture, okay, of a non-changing reality. That is, a photon going through something, so it doesn't break the experiment. And they just run the same. They just shoot photons over and over and over and over and over again, and take a pile of pictures of fundamentally different experiments, different photons. Okay, and then they call it a picture of one photon, because all the photons do basically the same thing. But it's hardly taking a high-speed photograph of an actual event. You're just taking a photograph of a composite of events. It's just not true. Okay, it's not really a photograph of a one reality. It's a composite average photograph.
They just shoot a very short pulse of light through the series of mirrors back and forth, and they have caught it being in different places. I mean, literally, they can see the pulse traveling as a pulse through the mirror as if it were a particle, because that is the property of a light ray. So I'm going to just...
Again, those are just compiled photographs of the same thing happening over and over again, and it's not one photon doing any of that.
By saying that it's really the nature of the medium that determines the dispersion. So in air, we have all these air molecules.
I mean, you almost make the obvious argument. The only photons they're seeing are the ones that didn't do what they were supposed to do. We're not even seeing, with those photographs aren't even photographs of the photons that are actually doing the right thing. They're photographs of the stuff actually doing the wrong thing. They demonstrate a location. The photon comes from a location, so you get to see where photons were. But you're not seeing the photons that are actually doing the experiment. You're seeing the photons that actually failed to do the experiment the way they were supposed to. The error photons are the ones you're seeing.
And they're constantly moving around and colliding. In fact, like the average speed of an air molecule in 70-degree temperatures is something like 3,000 miles per hour. These things are just incredibly chaotic. And so when you try and send a sound wave through that chaos, every single time it collides into a...
Yes, and it breaks the chaos. That's the whole point of what sound is doing. Sound is saying to the chaos, I don't care about chaos, because I'm going to hit something fast enough. Okay, bang one thing into another thing fast enough, okay, that it's all going to be kinetic now. There's no adhesion anymore. Adhesion is broken. So none of the molecules stick to each other. None of the molecules are connected anymore because they hit them fast enough. So it's like pulling the sheet from under the glasses on a table. If you do it with sufficient speed, the glasses don't know what happened. It's like, oh fuck, the tablecloth's gone. And you're doing the same thing to these atoms when you get to the speed of sound. So when you create a vibration that's quick enough, you break the adhesion, and now they're just going to hit each other like kinetic balls.
Another matter particle, let's just send it to a different direction. But suppose that we froze the air, and we put it in a very neatly arrayed order, all in rows and columns, right? Suppose we took our air and we did that. So,
right, now you're in big trouble because that geometry of equal distances, the cube, has diagonals that are a big problem. Distance is different, so it's not going to work.
If our air was like that, then if I then made a wave, like I pushed one particle on the left, then it would neatly only propagate to the particles into its immediate right. It wouldn't spread out. It would just go bump, right? It wouldn't go bump it, it would go straight, right? And the wave would not necessarily disperse. And pretty much any wave action propagating through this neat array would only push its immediate neighbors and would not go careening off in some random direction like it were an ordinary sound wave. And also, I see some people have been putting up flags. Like I said, if you have a question, please put it in the chat, and I'll try and get to it if I see it.
Yeah, I just don't think you can make that geometry small enough. It has to be levels of tiny to be able to have the ability to make a straight line between 2 points, 2 distant points. It'd still be very difficult to make a straight line through your geometry. It'd have to be insane, you know, so many levels smaller than.
So far, I don't see any significant questions. So as I was saying, that if the medium were neatly ordered, it wouldn't necessarily cause a dispersion. The dispersion is really not a fundamental property of a compression wave. If given the correct medium, a compression wave would do exactly what we need it to do, or again, which is for have maintain its exact direction and not disperse. All right. So this is what I'm trying to say, is that in an ideal, well-organized, frictionless medium.
Yeah, I don't think dispersion is a real thing in the sense that it's caused at the source. So I don't think photons are dispersing on their own. They're dispersing in the sense that they're the individual atoms that are releasing them. So the individual rays are very coherent, but the group of photons are not. So they have slight variations in their trajectories, and over distance, those will show up.
Medium, a wave would not disperse, would maintain exactly the same shape and width as it was originally generated with. And so I contend that this is what happens in the light medium. I did mention that we have this neutron sea, or I call it the positive electron sea. This sea is so dense that it could be said there are no spaces between the particles for them to move independently one of another, right? They're just all just...
I guess the thing that would really just end this kind of conversation is if we had a real good model of just molecules moving like water or sound through the air, and people could see that it's just little bits hitting little bits, and recognize that this idea of concept of wave is only an illusion of group behavior. Every little soldier is saying, I'm going to run towards that Nazi and shoot him. So every one of them is saying, okay, I'm going right there, I'm going right there, I'm going right there. They're all individual little soldiers. But yeah, if you line them all up and say go, they're going to look like a wave. But they only look like something. They aren't a wave first. First, they're a bunch of individual soldiers just going in a direction.
Jammed together, no extra space. So this basically eliminates the possibility of there being a lot of random motion to deflect waves like there would be in, say, a widely spaced medium like air, where each particle has a lot of independent velocity and a vector direction that can knock the wave in all kinds of different directions.
Well, all the mediums have one thing in common, in a sense, right? Well, I mean, like I said, you can even make this sound thing go through metal. So I mean, it's a vibration. So obviously, how close molecules are is only relevant to the speed. It doesn't really have anything to do with the fundamental function. And I suppose you could argue that there'd be less variance in positions. So as is proven, the steel rod, 50 feet long, I can stick it on something that's making a sound, and I'll get a very true representation of the sound. I can make a little thin wire, right, the old tin can thing, and I can get a very true representation of the sound, where the sound traveling just regular distances can get all screwed up by just humidity and temperature, and the wind blows and the whole sound sounds crappy. So clearly, whatever the phenomenon is, its speed is variant based on, I would argue, how close the atoms are to each other, and but the function of the actual compression of the atoms is the same. It's still electrons on one atom, the shield on one atom pushing on the shield of another atom. The electrons pushing on the electrons, and it's the compressibility of the electrons, that is the molecules, the atom structure, how much pressure those electrons are under will dictate how fast the rebound speed is into the next, into the next, into the next. But I don't think it's as, clearly the sound moves much faster in steel than it moves in air.
So the reason that we can justify light wave traveling as a ray is that the medium of the possible electron C is such a highly ordered array of particles which do not cause the dispersion of the compression wave. So,
again, the compression wave, if you're going to be at all honest to the physics, you have to say the pushing of particle into particle, the doubling of the dominoes, or however you want to say it. You know, dominoes go from being like this to being, hey, I'm 2 dominoes here, and then I'm 2 dominoes here, and then I'm 2 dominoes here, something like that. But that's all this compression is. It's made out of something that isn't, you know, it's not, it's soldiers first, wave second.
This justification of the light traveling as a ray, and showing how this leads to the behavior of polarization, we can successfully explain why sound waves cannot be polarized, but light waves can be. And there is no contradiction. It's just a difference between the type of mediums. A medium, which is consists of randomly chaotic moving particles, will cause, obviously, this.
Yeah, well, the difference is there's no rays of sound. Okay, sound isn't rays; it's individual molecules, and they don't have any ray form when created, when stripped. Again, you're moving the medium quickly enough to break the adhesion. So, you know, whatever the adhesion strength of the medium is, that's the speed you have to go to create the perturbation. But that's it.
Version of the wave. But if you had a tightly packed, basically motionless fixed array medium, then we would expect that the waves would in fact generate and propagate as these wave packets, and they would travel in a specific vector direction, and they would be, like I said, literally traveling like a pencil in a light ray.
Again, it's not a pencil, and again, you're not saying it's literally, you're saying it's a wave, so why call it a pencil? It's literally traveling like a pencil, except it's a wave. That just doesn't say anything. You got to explain it as dominoes, you got to explain it as steel balls hitting each other, or you got to explain it as some sort of thing, this pencil. You can't just say it's like a pencil wave. I can't, like I said, I have good imagination, but I can't make a pencil wave.
Once it gets set going, you know, this can be from a star billions of light years away, it will just keep on traveling through space as if it were a bullet. Although it's not a bullet, it's still made out of the individual compression waves, as if we had a sonic wave.
Yeah, as if we had a bunch of dominoes flipping, and the dominoes just flip back up. So you're just saying, okay, we're going to make the universe out of little round sticks, and you know, unidominoes or whatever. So they don't have a preferred direction. And you know, you can somehow make a path, you know, on any line that's a straight line. So even though we don't have geometry that allows that, because the geometry is always going to force it into these lines that are straight and lines that are not. Anyway, so let's just, you know, and you're just doing this thing where you're just saying, okay, the stick hits the other stick, it hits the other stick, hits the other, and the sticks just pop back up after they travel their wave. And I'm saying, why would I make the universe that complicated? Especially when I have to do those stupid dominoes in 3 dimensions somehow. I mean, why would I bother with that crap when I could just throw a rock? You know, why make this? You know, you're making the universe into this complex thing, right? I push a rock off a cliff, the rock falls down, hits the water. You're saying there's a whole bunch of complex universe that's making that rock go to the bottom of the water. I mean, it's just, why make it complicated?
These are coming from this speaker, which only shoots the energy forward in only one particular vector direction. So, okay, I think I've beaten polarization to death there. So let's go on to the only other experiment that I know of that would indicate that that a light wave is something different than a sound wave, and that would be the photoelectric effect.
Well, clearly they're different. So again, I don't think there's any way to not say they're fundamentally different. The scale of the one being tiny micro, and one macro kind of thing is huge scale difference between the dominoes of the mediums, if I have to accept their existence. We're talking about a grain of sand versus the moon kind of difference. They do behave differently.
Now, the significance here is that that no matter the intensity of a particular frequency of light, it just simply doesn't have enough energy to eject an electron from the surface of a metal. So this cannot be understood classically.
So again, these statements people make, this cannot be understood classically, as if they have imagined all the possible explanations and debunked all of them. Nobody has done any of that. I don't think anybody's even spent 10 minutes thinking about, well, yeah, let's think about it if it was particles. I don't think they've spent 10 minutes, 10 whole minutes at one time, one of these people, Einstein, any of these, I don't think they spent 10 minutes considering it that way. And yet they say, oh, there's no way you could do it classically. You know, yeah, there is.
Because if the EM wave is exactly like sound wave, then it should have,
again, if it's a wave. So again, they just never even consider the possibility. Okay, well, what changes the way bullets behave? Let's say I have a stick and I put it in the ground out somewhere, you know, a 2x4, and I want to knock it over, right? I put a heavy weight on it, you know. So, and you know, and I say the only thing I have is bullets in a gun from 50 feet. Is it possible? Can I figure out a way to shoot the bullets at just the right weight to start it wobbling so it'll fall over? Can I create a tipping point and tip it? Oh yeah, I can. There's a classical explanation that yes, the electrons have what's called a tipping point. That is, you need a certain kind of momentum, a certain kind of resonance. You have to create a resonant frequency in the electron and then it flies out. But if you're off resonance, no, nothing happens because all the energy defeats itself. The electron is moving this way when your next bullet hits it and it just defeats the momentum. So all you have to do is know what the word resonance is. All you have to do is know that resonant frequencies can be very destructive. And then you can recognize, oh wow, I mean, they can be destructive in the sense they create, they store energy. Resonance means energy storage. It's retaining the energy, right? And so that's why it's released. Not complicated at all as an explanation. Really Newtonian, simple, completes the picture, and all I had to do was know the word resonance, tipping point, you know, and momentum. There, we're done. And frequency.
and amplitude, right? You can have a little wave, or you can have a big wave, right? Of any frequency. So you should be able to turn up the amplitude of the wave in order to increase the energy to any arbitrary amount you want. So you should be able to create enough energy to eject electrons from the surface of a metal.
Right. So we know that that's just not true, right? There's lots of circumstances where if you put the wrong frequency in, you get nothing out. You put the right frequency in, you get everything out. Huge harmonic volume increase. So you put the wrong frequencies in, you get meh, 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 meh. You put the right frequencies in, you get whoa, you know, big giant sound.
Just by increasing the amplitude. But this doesn't matter. So no matter what intensity you raise a particular frequency, it just doesn't have the energy to eject an electron from the surface.
Again, it's that it has energy, but it can't do it if it keeps destructively destroying the previous energy it puts in. So if it's destroying its own energy, that is, it put energy in, and it's now going to defeat the function of that energy by crashing, you know, doing this, crashing into each other instead of doing this, pushing. So you're not increasing the energy of the system with each impact. You're decreasing the energy of the system with each impact. That's all. Simple equation.
So it was naively thought that the EM wave must be something completely different, since this cannot be explained classically.
So he says it again. I mean, it's just so arrogant. These people just keep saying it cannot be done. It cannot be done. It cannot be done. And I don't even think they tried, and they have absolutely no evidence anybody else tried. That any effort was made to try to do it, and yet they claim it can't be done, and they never even sewed some feathers on. They never even tried to flap their arms. They never jumped off any cliffs. They didn't jump off any sheds. They didn't have any helicopters. They didn't try at all, and they just keep saying it can't be done. Fuck.
However, this is once again a needless conclusion, and I would say that it's critical to understand what is meant by increasing the intensity. Now, this could mean taking the same light source and increasing the amplitude of the wave. That's true. However, oh,
You can't increase the amplitude. So again, just the number of photons. So yes, the point is you can hit them with the wrong frequency all day long, and you're just destructively interfering with your own agitation. So you're just not agitating to the maximum effectiveness. Hit with the right frequency, it pops right out. It's just obvious. It's a resonant phenomenon.
light, especially visible light, which is what the type of light they're using in this kind of experiment, is produced by atomic processes where an electron has to jump a particular quanta and emit a quanta of light in the process. So
again, that's their theory. You're already pointing out how they have a lot of wacky notions. This whole notion that electrons are jumping somewhere and doing all this stuff is just the way they've interpreted the data, and this isn't the only way photons are emitted.
we think of this as like an ordinary compression wave, you would think of this as like a single pulse. So you'd see, as light is emitted from this electron transition, you'd see a pulse, boom, right? Boom. Every single time an electron, you'd see a single compression wave, like a pulse. So the length of the pulse would determine the observed frequency. It could be boom, or it could be boom.
Right, and it's obviously got to keep doing that, though. The photons are obviously a ray in ray forms. They're little dot, 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 dot. So they're obviously, they're doing something, machine guns. All right, maybe they don't have 500 bullets, but, 10 bullet machine guns. But they're machine guns. They're shooting the stuff pretty quickly from the same location, pretty much. I mean, obviously the atom is moving a little bit, and that can create polarization. But other than that, it's pretty coherent. But shooting the bullets from the same place.
But since light is generated by atomic processes, and that happens at fixed distances, however you think that happens, it would be expected that the amplitude of these waves would be a constant. I mean, they're the same.
Again, the amplitude is based on how many you shot. So that means how many atoms are shooting the photons. It's the volume of photons, or the length of the rays of the photons. But it has something to do with the volume, the amount of pencils. So amplitude is about the number of pencils. It's not about any particular feature of the pencils themselves.
Saying it from A to B, it's got to do the same thing every time. You can't make a bigger amplitude, whatever amplitude it's at, right? A certain would be fixed. So since this light is generated by atomic processes that happen at fixed distances, it would be expected that the amplitude of these waves would be a constant. So the only way you could increase the quote-unquote intensity would be to increase the quantity of wave packets that are being generated by the source.
Right, so the number of pencils in the rays, you can have them closer together, and therefore in the same amount of time you can have more pencils. So it's just about, again, red light would be pencils separated by a distance of like that, and then blue light would be pencils this close. So obviously in the same amount of time you can get more pencils in blue light. But again, it's not even going to matter if the resonance frequency isn't the right one. So the fact is the blue light just happens to be the right frequency. The bullets are the same value. Yes, you can get more energy with in the same amount of time with ultraviolet light, but you can also, it also has the advantage of being a specific frequency that happens to be the resonant frequency of the electron's tension. So for different materials, it'll be a different resonant frequency. Different atoms are going to, the electrons will be under different tension, and they'll vibrate at a different speed. So it's going to be metal specific, and it's going to be compound specific, what affects the substance. Just like microwaves only affect water molecules and this and that. Certain kind of molecules, and they're the ones that get affected, get agitated. It's because it's the resonant frequency. The microwaves are the resonant frequency of the water molecule, the electrons on the water molecule.
So we would see this as, we see this in our eyeballs as greater intensity, but only because the number of wave packets has increased. The amplitude of each of the individual waves is absolutely identical and can only contain a fixed and a limited amount of energy.
So again, this is, I just brought this up with microwaves, right? It just seems kind of obvious that the photoelectric effect isn't any different than all these other effects we see in the real world. That clearly, it's about the resonant frequency. A building can be impervious to a 7.0 earthquake, but a 3.5 will knock it down. it just has to do with this. The frequency is fundamental to structure. Structure has a frequency vulnerability. So every structure has a different way to push it to tip it over. Every weeble will fall down if you hit it with the right frequency.
There's another reason why people think that the energy of a proton is quantized, and in fact it is. But it's still a wave. It's not an incoming physical particle at a fixed velocity.
Says you.
So this is why if the frequency isn't high enough, each wave packet is still incapable of providing enough energy to inject an electron.
So even this term, you've accepted their bullshit language, the wave packet. So if, do I call the soldiers on the battlefield little wave packets? Because, you know, if I put all the soldiers together, it looks like a wave. So we'll just call each individual soldier a wave packet. It's also very cute. It's just crappy language, wave packet. Again, how do I take my rather extensive imagination? I can imagine things with millions of penises, and I can imagine all kinds of things. How the fuck is it that I can't imagine what the fuck this wave packety thingy is? It's just jargon.
Surface and photoelectric effect. It doesn't matter how many you have or how often they hit, they just don't have enough energy to do the job. So this explains the photoelectric effect by showing that the waves that are generated are created with all the same amplitude. So increasing the quantity or quote-unquote intensity has no effect, and you would predict that. And this is all easily explained as a property of the EM wave, which I would contend is just the same as an ordinary compression wave like sound.
So again, you still haven't explained why certain sounds cause the electron to pop out and certain sounds don't. So you haven't used the word resonance or anything. You haven't explained why. You still haven't explained the effect. Yes, their explanation is stupid. I'm just saying, what's your explanation? I haven't heard anything. They say ultraviolet light has more power innately somehow. They just say it's more powerful, blah, blah, blah. It has superpowers. When it's made exactly the same thing, bullets.
No exotic explanations are required.
You need some you don't need an exotic one, but you're not providing any. Why the difference? Why can I hit it all day long with bullets going bang, 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 and they don't do anything, and they happen to do something if I go bang, 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 bang? You haven't explained that yet.
To explain either the photoelectric effect or polarization. So we come to the end of my paper here, and it can be seen that the EM waves in general can be seen as being caused by a simple compression wave, which is exactly the same mechanism used to transmit sound waves.
So again, take away, you don't need the word wave. The word compression is basically just saying something rather than nothing. Okay, so you can just cut this mathematical thing down by just saying, just cross that out. The wave, yeah, get rid of the wave thing. Compression is just a quanta of energy now. So we're just saying there's more mass in one location than there's in another location. There's more momentum in one location than another. They're closer together in one location than another location. We don't need to do all this wave crap. I mean, you know, going back to the soldier analogy, you could have a whole, you know, they do this performance art with soldiers, and sometimes they do it with their marching, you know, and they'll create a wave in their marching, like they'll march at a constant rate, and then the one row will go one step faster, and you know, and then the next row one step faster, and they'll create waves in their, you know, patterns in, you know, audiences in stadiums will all stand up. Do you really think it's a wave of something? Something's waving? Nothing's waving. Individuals are reacting to the individual next to him. He just stood up. I stand up now. Then I sit down. He stands up. Yeah, I get it. Not complicated. So despite being called electromagnetic wave, the EM wave has absolutely nothing to do with the electric or magnetic field. It could be so. You don't need the notion of a field would be the first thing to say. You don't need two of them, that's for sure. Okay, so let's you and me put together an argument that just says we don't need two fields, and we can explain why this two field notion isn't really the truth, because you can see it in Maxwell's equations. You can see that they've bisected the speed of light. And we know these things don't move at half the speed of light. We know the electric field isn't moving half the speed of light. We know the B field isn't moving half the speed of light. We know they're moving the speed of light. So we know that this bisection is artificial. There is no need to have two frickin' fields to play with in your math. One field will do it all if you just recognize that charges, okay, are monopoles and magnets are dipoles. There. You know, and that has an effect on the durability of the field effect. But there's just the one field of force. So I would argue, so we won't agree on that. But yeah, there's no need for an ether. There's just soldiers. I either release a bunch of soldiers and create a field of soldiers, or I don't have any soldiers and there's no soldier. So there either is a soldier or there's not a soldier. That's it.
We have simple compression waves propagating in the very dense and non-dispersive pos-electron sea. The only two contradictory experiments involving polarization and the photoelectric effect can be trivially explained if we understand that EM waves travel as rays and light and is generated by atomic processes.
Well, you have the third one, which is photons being affected by gravity, which is not exactly related, but it is something you have to account for. If you accept that notion, then you have to also explain why these photons are impervious to magnetism, and yet they're somehow pervious to gravity.
Which lead to fixed wave amplitudes. All right, so that concludes my paper. Now, so I want you guys to prepare your questions. I need to go grab a drink of water, and I will be right back. So if you have a question, please raise your flag, and we will go through your questions in order.
Sorry, this will be kind of funny, so we'll play this because it's, like I said, it's just evidence of how the conversation just doesn't work. You know, we have to learn how to do this better.
Okay, questions, and feel free to disagree with me. Since I just blasted up this paper just like 2 days, and I made a lot of assumptions, and some of them could be wrong. So first we have Ian.
Thank you, Franklin. Well, thank you for the presentation, because I only saw your paper about 20 minutes before the presentation, so went through it very quickly. But you've expanded on that quite well, so thank you very much. I've got some comments and questions, I suppose. Well, a general point first is that basically, I mean, I'm tickled that you've basically accepted my thesis, but you, as you said, you've actually gone a bit further.
He hasn't accepted your thesis. He's merely theorizing something of a similar vein. That's how you put it. Again, I'm not saying Franklin has accepted my notion that there is no electro and magnetic field. No, he's come to the conclusion also that it's rubbish and there's got to be a better explanation. And both of these people are proposing explanations that end up being worse than the original one they're trying to dispose of, in my opinion.
You know, taken not merely there to be an analogy between sound and light, but that they're basically identical. Now, you've obviously justified this quite cogently.
So again, they say identical, which is just you know, again, there has to be some, you know, rules about you can't get too sloppy with the language. And we know that they're so distant from each other. I mean, grain of sand versus moon. I mean, there's just such a substantial difference. I mean, it's probably bigger than that difference. I mean, it's a huge difference, okay? The vibration of an electron versus the collision of molecules.
And I have an open mind on the matter, but I feel that one mightn't have to go to that extent at present, because as I think I've shown that from the classical theory of electromagnetism, you can derive the perfect analogy between light and sound without saying that it is actually physical compression. You can say there's an analogy between the electric stress, if you like, and the magnetic strain.
Why would I bother with an electric stress and a magnetic strain? Again, why would I bother when there's absolutely nothing to connect photons to electricity or magnetism, except for the fact that the photon has every appearance of being exactly the same substance that is the force. Those forces are moving at the same speed as the photons. The photons are actually the force. You know, they're not. They're the force. There's no force without them. That all these things are the same thing, just in a different configuration. So the pencils without a length, or you know, without a frequency, yeah, gravity. Pencils polarized in the sense of you know, electron force, proton force. There, simple. You segregate the two forces, and you have an effect called magnetism.
Now, the conventional transverse nature of the electromagnetic wave, although actually you possibly contest that it's electromagnetic at all, but the transverse nature of this, if it is electromagnetic, comes basically from the Gauss divergence laws. So it's actually even more fundamental than the Maxwell equations. The Maxwell equations will be based on that. And
well, we already know that too. So look, let's all just concede. Maxwell didn't create something out of nothing. He took all the stuff somebody else made. He took flour and milk and all, ingredients other people had already made, and he just put those ingredients and made bread. So he didn't invent something. He just recompiled what already existed into a new form.
There are things like Faraday rotation, which you put a magnetic field and you get this sort of rotation of the wave, and there's a Thomson scattering.
Again, it's Compton, not Thompson, but they just throw out stuff. Okay, you just threw out something. Rutherford did this, or somebody did the, and we don't have any evidence that that's a real thing. And we don't have evidence of exactly what the statement is confined to, what experiment was done, and what conclusions could be drawn.
You get a sort of scattering when, say, an electric charge, an electron, actually collides with the electromagnetic wave. This can be considered.
So again, he's calling it an electromagnetic wave, even though he says he's debunked the fact that there is electromagnetic waves. So let's not call them that. Let's just call them photons. I mean, radio wave photon. They're all photons. Photons. Let's just call the whole electromagnetic spectrum just a bunch of these photons, and there's visible ones and invisible ones.
Basically, a low-energy Compton scattering. So there may be two things that one might have to explain or explain away.
So you have Compton scattering. What was the name of the other one?
Faraday rotation. So Faraday rotation is the B one, and Thomson scattering is the E one, if you like.
Completely unnecessary. It's just the way they're describing the field at that circumstance, but it's the same field. It's moving the speed of light. Again, they're this bisecting of monopoles from dipoles. That's all this is about. That's all that's what distinguishes E field from B field, okay? Electrofield from magnetic field. The only thing that distinguishes those two things is one is a conversation about the monopoles, okay, of negative and positive charge separate from each other, and the other one is about dipoles where the two charges are right next to each other, and that's it. There's nothing else here. It's the same thing. You're just talking about when they're so close to each other they become a mixed product. That is, at different distances they'll be a different thing. A dipole has that feature. Dipole means that at 1 inch it can be a positive charge, and at 10 inches it's a negative charge, and at 50 inches it's no charge.
You've postulated a sort of a more orderly ether. I postulate an ether, but I don't go as far as you to ascribe.
Again, you should, and the point should be, what is the real hard evidence that indicates there's anything called an electric field or a magnetic field? Do these fields exist in any real way, in any detectable way, as anything like a structure that actually exists that's bisecting? So let's first say there's not two fields are necessary. That's the first argument. And then the second argument is going to be the field doesn't mean anything. The force is the field. Without the force, there's no field.
Particular properties to it. But you've described a more ordered system rather than the random movement that we have in ordinary gases, which obviates polarization.
No, it doesn't obviate polarization. The way the wave is created obviates polarization because it's not rays. You're not creating rays of sound. There's no sound rays.
Okay, I wanted to make clear that it's not as messy as a gas, but it's more like a liquid, but it's not as ordered as the crystalline structure of the Epola. So there was a comment about me supporting the Epola, and it was like, no, I still believe the Epola is mostly right, but this idea that space is a solid structure, once again, motivated by people's irrational need to support a transverse wave, is actually not necessary.
And your ether is also not necessary. Your structure, let's create a platform for the universe to display itself on. No, there's no display for the universe.
Yes, Cornelis left that message. Okay. I mean, all I would say maybe is I think your explanations, while cogent, are a little strained. I mean, there might have to be other reasons why you accept your model first before maybe trying to have to explain these things away. I mean, if we're incorrect and the electromagnetic wave is thus and has transverse electric and magnetic varying properties as given as derived from the Gauss law, well then probably your explanations are.
Well, again, so the guy's saying he agrees with him that there's no two fields, and he's just defending the idea that there's somehow two fields as dictated by Gauss, and there's no such thing. Gauss has this assumption that there's no magnetic monopoles, but clearly electrons and protons are the magnetic monopoles. Clearly.
Unnecessary. Well, one other thing which seems to be a little new, by the way, is you talked about the...
I think it's backwards. I think that Maxwell's explanations are unnecessary in light of my explanations. But somebody's wrong here.
I mean, that's right. Who do you take first?
Well, again, Maxwell isn't wrong. It's just that he's bisected something that doesn't need to be bisected. He's taken something that's always the same force, and for one set of circumstances, he'll call it an E field and give it a couple of different changes. That is, instead of R cubed, it's R squared. And then in the other case of when it's a dipole, it's R cubed instead of R squared. Yeah, that's what I meant to say. That's all. There's not a huge amount of difference, except for the fact that the fields have different strengths, and that's it. And the strength really only has to do with the fact that it's unpolluted. The dipole is polluting itself. It's diluting itself with distance, where the monopole is not. It's almost like saying you could have harmonics. You could have sounds. And if the sounds are far enough away from each other, they don't interfere, don't create any noise, don't break down. But if I put the two sounds close to each other, you won't hear either one of them anymore. You'll just hear the noise they create when they mix.
We might have to do a lot more experiments and see whether there are contradictions between your two systems and which one gives the more correct results. I said that recently, actually, in regard, I think we made a conversation with Bob Rather, in regard to the Weber.
Why not just have the conversation about what is the evidence for these bisecting fields, these perpendicular fields? What evidence is there they exist? What hard evidence, what experimental evidence demonstrates their existence? And is there anything in Maxwell's equations that necessitates their existence? That somehow you're not allowed to derive the equations by just throwing out the word E and B and just have, F or whatever the word would be for force.
Alternative theory as well. I mean, you could argue until you're blue in the face about this, but really we need more experiments to see whether Maxwell or Weber would be nearer the truth, and then we can sort of drill down a bit further. So that's my general comment. I mean, as I say, I agree with that.
Well, they have absolutely no experiments. That's what I'm finding out, right? So they're saying that Maxwell's equations basically dictate that in sound waves there's some difference between the redshift of emitting, caused by emitting, and the redshift created by receiving, by moving. So the movement that changes the emission of a sound is somehow different than the movement of recession. So if I move forward, I somehow do something different than if I move away in terms of shifting the perception of the sound. And that's what we're talking about, the perception, the measurement. And we know that the one emitter is creating a real effect. That is, it's creating the sound. So obviously it's doing something real, where the recession is doing something unreal, in the sense it's converting the reality through a broken ruler that's moving. But the point is there's no evidence, physical evidence, that this is real. So here we have something that Maxwell's equation says is real, that I haven't been able to find any evidence that it's real. Where's the experiment demonstrating that the redshift caused by the emitter is different than the redshift caused by the receiver?
Actually, your thesis, you agree with mine, but I think you've gone a bit too far, and I need a bit more convincing before I accept that. Thank you for present anyway.
Okay, great. So Michael Antesky, basically.
I'd like to draw an analogy not with sound but with ocean waves.
So this guy goes way off the subject. Just he has some kind of he's doing the origin of the universe thing. It's all started with wave, and then the waves caused waves, and then the waves caused more waves, and then that created an ether, and then there was waves in the ether, and then the ether caused another ether, and then the ether would stop at the ether. It doesn't make any sense at all.
With my ether model is based on the idea that it was originally a universal oscillation, which transitioned to a universal vibratory ether. Well, with the vibratory ether, the outward vibrations energetically align, and in the presence of energy.
So again, we're talking about photons, emission and transmission versus sound through mediums. That's the subject, and this guy is just saying, "Oh, fuck the subject. I want to talk about my wacky Hooby theory." Franklin Who? Yeah, Hooby.
You will have entrainments and other linkages of the ether units, individual vibrating ether units. And now if you take the ocean, you have the surface of the ocean has these little waves, and deeper down you have surges of energy, currents, and this and that. But at the surface,
caused by completely different physical mechanical things. The waves are caused by one kind of disturbance. The thermal action is another kind of disturbance. It just doesn't have anything to do with each other.
Surface, the density of the vast sea is not present, and you get these small waves go back and forth. But then as you come to the shoreline, the waves become accentuated. You lose the attenuating effect of the deeper water, and the amplitude of the waves increases. Now, to draw an analogy with the ether model, you have a vast sea of...
Yes, because the volume of water changes. So obviously the ability of the wave to be manifest as you reduce the volume is kind of obvious.
Very tiny elemental ether units. And then all of a sudden, you could have, in the presence of an source of energy, let's say an electric current, or let's say a source of light, photonic or electronic energy in an area, there would be an increased transition of ether to a quantization.
Let's understand, ocean waves aren't anything like sound waves, in the sense that ocean waves do have variable speed. So, it's not the same. You can't do this constantly comparing things that aren't the same thing.
The ether and the formation of larger and larger units by entrainment and other linkages. And so the wave effect would be increased. It would be like a shoreline effect. You'd see these really dramatic wave effects, because it's like the waves way out in the deep, where the ether is so dense that the waves are smaller. But
that's an interesting observation.
No, it isn't. If you want to be honest, Franklin, you should just say, well, you're completely off the subject and whatever, buddy. I'll do that next time you make a presentation. I'll start talking about how, bananas are all clones, and, they have green leaves in the plant, and it gets the sunlight, makes bananas, and, I'll talk about something completely fucking different.
I'm going to try and take you back to what we're talking about, which is the nature of the electromagnetic wave.
Well, that's
what you just
about.
said seems to have no relevancy to the conversation. So how is this relevant to, whether electromagnetic wave is this magnetic electric thing, or is it like a sound wave? How is that related?
Well, the energy that we observe is from our vantage point, which is the quantum forces vantage point, where we.
So he just keeps doing it, right? Quantum vantage point bullshit. Just keeps pretending. You're supposed to explain how the moon is like the sun. I mean, like the sand. So just explain what they have in common or what they don't have in common, but stay on the subject, jackass.
And spin and these other mechanisms. Whereas what I'm saying is that this is a shoreline effect. These waves EM waves that we see represents a shoreline effect of.
It doesn't represent it in any way. The shoreline effect is again, it's a whole density problem and the speed changes. So where's your evidence of any speed change in light? Where's the frequency change? Where's any of this stuff fucking happen? You're just so full of shit, fella. You're just it's unacceptably rude, in my opinion. He's so off the subject.
The transition of vibratory ether forces into quantum units like electrons, in the case of an electric current, or photons, in the case of light. And
how can this be a shoreline effect?
It's a shoreline effect. I'm saying it's a shoreline effect, and the reason we see it so much as a wave is because the wave effect is accentuated by the transition from all these smaller units into to the larger quantum.
I mean, you're talking about the reception of electromagnetic wave. So when the star sends its light on the way to Earth, you're saying that it's like a shoreline effect when it finally hits our eye. Is that what you're saying?
Well, I'm saying it happens all along the whole length of the ray. There's a transition between etheric vibrating units with a photonic vibratory pattern to electrons all along the way. But when it reaches Earth, the region of our sun, there's more of an accentuation of the photonic transition because of the energy. Because if you
it's just gibberish, just fucking nonsense. it's clearly the same photon it leaves is the same photon received. It does, if I moved half the distance, I'd receive the same photon. The photon would be in the same condition. It wouldn't be more tired. It wouldn't be dirtier. It wouldn't be any of that crap. Same fucking photon.
You have more energy. That's when the alignment of the ether and the entrainments and the linkages and the formation of the quantization thing. I mean, that's my theory. That's my
yeah, it's your theory. Gibberish, gibberish, gibberish. So you just did this. You just sat there and said to Franklin, I'm just going to go gibberish, 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 gibberish. How's that? Is that a response video?
Okay. All right, so Bob, you have raised the flag.
I think Harry has raised his flag much earlier.
Yeah, Harry wants to say some snarky shit. So yeah, let Harry go first. Harry the snarky fuck.
We should try to go in order. But yes, I have raised my flag. I have a comment.
Go ahead, Bob.
Thank you.
Go ahead, Bob. Harry the obnoxiously loud asshole, too.
You, Harry. I think there's a distinction between an electromagnetic wave created by taking a charged particle or charged body and raising it up and down, oscillating like in a dipole antenna, which radiates in all directions, and an electron in an atom which de-excites from one quantum state to another and emits something, but that's only in one direction. And yet the electron, you could go and say from a higher state to a lower state is a certain movement, but what's generated is not an omnidirectional wave, but a very directed wave. So I would suggest thinking about this.
So again, we have this idea of what exactly does an antenna do. So they're thinking antennas create some sort of, the stuff goes up and it has the stuff is peeling off, like the antenna's peeling off a piece of itself. Peels off a piece of itself, and then it goes up, and then the piece goes down, and this piece goes out, and none of that's happening. It's radiating light just like, it's radiating photons just like a light. Just like a filament, a heated filament. The photons are just flying off of the damn thing. They're not peeling off. They're not doing any of this stuff. They're being shot at a frequency at you. And the radio wave just makes that more obvious because it's like having a light that you could turn on and off at the speed of the frequency of the light. Obviously the light works in a different function because the electricity is creating, every atom shooting its photon at a different time. And the radio wave is really just saying all the photons leave at the same time. But that's the only difference. It's a bunch of photons, a bunch of photons, a bunch of photons, just radio coming off the antenna.
Distinguishing the two cases. And so there may be two different kinds of waves propagating. One, like in the dipole antenna, I would suggest is, as you were saying, maybe like sound waves, and it goes in all directions. Whereas the transition of an electron...
They all go in all directions. Again, that's how radio works. It's obviously going in all directions.
An atom may generate a soliton or something else, a more part.
So that now we're to the solitons. So these are, like I said, I don't know what the whole history of these people are, what the kind of cabal is, but okay, that's that Bob guy's theory, and this soliton thing, and clearly the Harry guy thinks that those two nutter religious guys are right about something, so he must be a soliton guy too, and whatever that is.
Ish kind of thing that is very unidirectional, has a direction, and is not emitted in all directions.
Unidirectional, so
directions. And so maybe you got to think about maybe there's two different kinds of waves involved in quote-unquote electrodynamics. That's my comment. Thanks.
Yeah, actually, I would totally agree with everything you said, because I believe that there is a distinct, a very large distinction between EM waves generated by atomic processes and...
no, it's gotta get this keyboard to work. So I don't know why he would agree with everything he just said when he just said something. His whole paper is full of stuff that doesn't say that.
EM waves generated by, like you said, dipole antennas. Although I would say that that all EM waves are directional, but in the case of, say, dipole antenna, you have billions upon billions of electrons, which I see as being literally pushed out and in the surface of the dipole antenna. And so it's only just directional because you are literally sending EM wave packets at every single direction out of your dipole antenna. But even with the dipole antenna, when you're trying to receive the wave, if you think of them as being like these tiny little bullets coming out, they're still better received by an identical receiving dipole antenna of the same shape and type.
Yeah, so it's obviously you're just back to the charge argument where the durability of the signal is going to have, it's going to go further if you have monopoles versus dipoles. The dipole will give you more, it'll matter if you're receiving it dipolarly, okay, receiving magnetic, but it won't mean nearly as much to a single charge. It's diluted by half from a single charge's perspective.
Because there's more possibility of intercepting these things. But the other difference between waves generated by dipole antenna is that I believe that the amplitude in those cases can vary. That the amplitude of a radio signal can genuinely vary versus the amplitude of light produced by atomic processes, which I still think has to be of a fixed amplitude, and it's of a fixed vector direction. So, for example, if you see positron-electron annihilation, they generate 2 gamma rays, and these gamma rays can be said to go in a particular vector direction, and they actually hit the detectors in one spot, as if they were a bullet.
So he's conceding again, as if they were a bullet, but then he's talking about annihilation events and all this other BS.
So yes, I would agree with you, Bob, completely that, yeah, there are these 2 cases, and but I think that would actually be the subject of another paper, which is what is the difference between visible light and radio waves. So now, Harry, you did raise your hand as well. Bill, raise your flag. So, Harry, why don't you go ahead?
What is your motivation for this? It's a big long dissertation. Why are you insisting that we have to throw away a satisfactory?
So, big long dissertation. It's the average length. Actually, it's shorter than most of these people talk. So it wasn't all that big long, and he clearly made his point of why he's doing it. He's doing it because he doesn't understand this transverse wave thing. He doesn't understand how it can mechanically work, how it can physically be imaginable, what mechanism could possibly contain this stuff. He's saying, you're not giving me nothing here. You're just saying dark matter at me or something, and I'm supposed to say, oh, okay, yeah, it's just like matter, except it doesn't make any gravity, and it's invisible, and, you know, I mean, it makes gravity, but it's invisible.
Why are you insisting we need to throw away a satisfactory model that served very well for over 100 years?
So he says it's a satisfactory model that served well for over 100 years, as if all the dumb models of the history didn't always serve well enough, even though they were wrong. And, you know, so we have plenty of evidence that you can have a wrong idea of why something works and still you can make airplanes and have a wrong notion about what's causing lift, you know, buoyancy versus trajectory versus, you know, lots of different arguments about why exactly planes stay in the frickin' air. We can have lots of theories that are wrong and still be able to fly airplanes. So what does that have to do with it? Oh, that's right, absolutely nothing. He made it clear. It doesn't make any sense. It doesn't make any sense to me. It doesn't make any sense to him. We're making a statement saying, okay, it makes sense to you. I can't imagine it, though. I can't even imagine why it makes sense to you to create some sort of thing that's going this way and this way at the same fucking time. It doesn't make any fucking sense how the simplest goddamn thing in the universe is doing all this bullshit.
Because it's wrong. No matter if it...
Okay, so do you have some proof that it's wrong? What's your...
Yeah, his evidence that it's wrong is there's absolutely no evidence that it's right, okay? That's the evidence that it's wrong, is that there's no evidence that it's right. So just like your silly gods, there's no evidence that the damn thing ever existed or ever could exist or anything. There's just no rational way to put it together and say, yes, there's some reason to believe in this crap. This is completely a figment of their imagination. It's a fairy story, and they have no evidence that these 3 pigs of electrodynamics exist. Nothing to back it up with. Nothing.
For proof that it's wrong.
Oh, yeah. Well, once again, my entire paper is proof that it's wrong. Proof that it's wrong is our inability to measure the actual rising and falling electric and magnetic fields.
Okay, let me stop you there. What proof do you need?
I need a proof, like you put a squid detector along the transmission length, and you should be able to do this, but have a transmitter one in, generate a low frequency radio wave, and along the path, you should be able to predict exactly where you're going to see the maximums and the minimums, and show me the time varying magnetic field, for example. That's something we can measure.
So you're saying that you don't think that an electromagnetic wave is composed of electricity and magnetism?
Exactly.
So some other asshole is talking over these assholes. Yeah, so he said this. Exactly. That's right. I don't think there's anything called a electric field or a magnetic field.
Exactly. I believe this is my contention. Has nothing to do with that. That's all in people's heads. That has absolutely no physical reality.
So you're saying that in effect, basically, that light is not electromagnetism.
That's right. Light is.
Yeah, whatever electromagnetism is. Again, so what is electromagnetism? Electromagnets make electromagnetism. So electromagnetism doesn't even say anything. What the fuck is electromagnetism? Is a regular magnet creating electromagnetism?
Not electromagnet. That's my main point. They may call it electromagnetism. It has nothing to do with.
Radio waves are not electromagnetism as well?
Yes, radio waves do not have anything to do with electric or magnetic fields propagating through space. Nothing. It's just like sound waves. I'm saying that it's like a sound wave.
Yes, that radio waves are just like photons, except they're at a frequency we can't see. Bingo!
It's just a compression and replication of medium. That's what we are seeing in the end. That's as radical a change as you can possibly get. I understand, but that's what we hear.
What is your need for this radical change?
So again, he just keeps harping on the fact that somehow this answer is just so obvious. Oh, it's just so obvious that photons are doing this, and they're in these two different fields that are bisecting somehow, and it's just so, and they're perturbating in this direction through these two fields at the same speed, and blah 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 blah. Whatever.
And the need for the radical change is because this conception of the EM wave as this electromagnetic field does not make any intuitive or logical sense.
Well, it makes a lot of sense to the people for the last 100 years. You seem to...
No, to what people in the last 100 years? To what people does it make sense to? So I'm just saying, let's put those in a category and let's show the people who actually say, I don't get it at all, right? I think if we would go out and survey people and show them, they're going to say, well, okay, that's what you say. I don't know. Go ahead and say so, but I don't have it. I don't see it that way. I certainly don't see light doing any of that shit.
Be the only objector to it.
Yes, that would be right. But then again, people didn't object to the idea that the Earth was the center of the universe for thousands of years. But that didn't mean it wasn't wrong.
Well, that's not really an argument.
Yeah, it is a very good argument. Okay, the fact that you people traditionally cling to bad ideas, that's what human beings do. They just love to cling to bad, stupid, retarded, idiotic ideas, and they just keep clinging to them and clinging to them and clinging to them. They won't let go of them. Like heritage, you know, it's like it's like they're preserving their race or something, is believing in this stupid fucking traditional notion that's just fucking wrong. And so yes, there's all kinds of evidence that's exactly what human beings do.
But I'm just saying that it's not an argument to say that everyone...
I mean, it's so profoundly under-evidenced. Again, there is nothing. There's no fucking picture of it. There's no indication of it. There's nothing. If they could bend a photon with magnetism, you might say, yeah, okay, this could be made out of magnetism somehow. But they can't. And the fact they don't even understand the force itself, which is the frickin' light is moving the same speed as magnetism. Quite obviously, the photons are a kind of magnetism. They are magnetism. That's why they can't be affected by it, because that's what they fucking are. Shit.
Do you agree that if I put a detector that detects electricity at the output of a radio antenna, that I will detect power at the output of the radio antenna?
Well, we know that's trivially true. The question is, how does that happen?
Yeah, it brings up the perfectly good counter-argument that exactly the same thing happens with sound. You electrically produce it, and then you electrically convert it and receive it. So you can do exactly the same thing with sound.
That's not what I asked you, Franklin. I asked you whether or not you agree that if I put electricity on the transmitting antenna, okay, well, what Marconi did and what they did in the very early days of radio was they charged up an antenna with a high voltage of electricity. So they put electricity on the antenna.
Yes.
And then,
again, and this is nothing that Franklin's going to disagree with. I don't know about high voltage. It was more like it's high frequency. But again, you know, people can make that kind of mistake.
And only prove that electricity generates EM wave.
Excuse me, I'm talking now. And at the other end...
Oh, excuse me, I'm talking now. Amazing. Yeah, you're talking shit, okay? Franklin clearly understands Marconi physics, so I don't think you have to explain that to him. So you're just being patronizing.
Okay, Marconi discovered that he could detect the electricity when they created an oscillator.
So he could detect electricity. So he thinks that the stuff traveling through the atmosphere is electricity, when clearly it can't be. It's an insanely stupid way to describe it, because it's clearly not electricity. Electricity is atoms banging, exchanging pressure. That's why it ends up creating light. Electricity has to move through a conductor. Oh, God.
On the transmitting antenna, which was electricity, okay, powered by electricity. He got electricity at the output side. Do you agree with that?
And I can create, radio waves without using electricity. I can create radio waves by vibrating a car engine or something. It's creating actually radio waves. They're being emitted through all the other stuff, sound vibrations, other vibrations, but it's also creating radio waves. No electricity required. All you need to do is vibrate metal.
Absolutely. That's what he did.
So then why do we need your model?
Because you can say the exact...
Why do you need your model? Electricity goes in, electricity flies through the atmosphere, electricity is collected by the antenna. So his vision of physics is that the electricity goes into the wire, goes through the atmosphere, and it comes back the other wire. That's his physical reality. When anybody who knows anything about physics knows, no, it's converted into a different form of energy. It goes in one form, gets converted into another form, then it's collected and reconverted back into the other form. Everybody who has any kind of brains knows that's what's goddamn happening. And they know that sound, when I shoot electricity into a speaker, the electricity isn't going through the atmosphere creating sound. So he's just a dope.
For the same argument that I apply electricity to the speaker, and then I have a microphone, and I recover electricity from the microphone. So does that mean that the wave traveled through this electro and magnetic?
I don't know why they can't figure out how. They got to have a strict rule that people have to close their fucking mics. Why didn't you just close everybody's mic? I mean, why are you allowing people to talk over you? It's just, you keep doing it. That's all the reason I'm complaining, is they've been doing this for a long time now, and they just keep allowing these unnecessary, degrades in the quality of these videos.
Fashion?
So you're denying that the phenomenon is a phenomenon of electricity.
No, I'm denying the phenomenon.
So he says he's denying that it's a phenomenon of electricity. He just gave him an example where electricity goes in one end, something completely different comes out, and it's collected again as electricity. So he's giving a perfect example that it's not electricity traveling. We're talking about what the hell's going between antenna A and antenna B. What the hell's traveling between the two antennas? And he's just dopily saying anytime I put electricity in, it's electricity. So now sound is supposed to be electricity. Because I put electricity in, it means I got electricity out, and it means electricity went through the medium. Bullshit. It's retardedly, immaturely stupid.
That this wave travels as a time-varying electric and magnetic field, which are traveling orthogonal to each other.
I don't really see the need to do that. I mean, it seems to me that's fairly well established by experimental fact.
So he keeps saying it's well established by no experimental fact. That's the whole point. What's experimental facts? What? Where's your evidence of two fields vibrating? Where's your evidence, your physical experiment that just obviously makes that clear? Shit.
So why are you denying something that's well established by experimental facts? I don't see.
It's not well established at all that there's two fields being vibrated. Where's the evidence of two fields vibrating? Where's your experimental evidence of two fields vibrating? You have no such fucking evidence. You have zero experimental evidence.
It's not established at all. This is what I'm going to contend. That nobody
sorry,
can show me any physical experiments that can recover the time-varying, say, magnetic field from a traveling electromagnetic wave, which you would have to.
I explained it to you, Franklin. I just explained it to you and how they discovered radio and how it works. I just explained it to you. So
and I just gave you an analogy that completely blows that away, that I can do exactly.
Yeah, he did. He just blew it away. He just wiped out this stupid hairy guy thinks he made a rational point. When, no, I can create lots of mechanisms where electricity goes in, something else happens, and then electricity comes out. Freaking waterfalls. Do you think the waterfall is electric? If I pump the water up a hill electrically, the water falls, and I collect it with a turbine. Does that mean the water's electrical?
The same thing with ordinary an ordinary microphone.
This basically is not logical, okay?
No, it's perfectly logical. What's illogical is this, how can there be a magnetic field or a charge or electric field without there being any charges? We know these electromagnetic phenomena travel through space through perfect vacuum where there appears to be no charge, for there to be there. I mean, it makes no sense that we have the electromagnetic wave as it's pictured.
And again, the fact that you think there needs to be the charged objects or material things, and there's a force that has to be, they're creating a change in a force. They're not, creating a force, they're changing a force. They're giving it a frequency, or they're segregating it. But that's it. They're changing a force, they're not making a force. They're converting movement into force. They're releasing something that's trapped inside the atom, energy. And they're releasing it in such a form, okay, that it has properties. What am I looking for? Ah, yes, battery. Sorry, you didn't...
Where it rises, and they rise in phase, right? The electromagnetic equations say that the magnetic field should follow the electromagnetic. I mean, you have a rising electric field, then it's followed by a magnetic field. And the magnetic field can then generate the electric field, but those have to be out of phase. So it makes absolutely no logical sense that you could have a magnetic and electric field rising and falling at exactly the same time. What happens when it goes to the 0 point, is what I'm saying. That it's dead. When electromagnetic and electric field go to 0. I mean, it's really 0.
So again, well, look, all their diagrams are wrong. There's no sine wave actually moving. It's just an illustration of amplitude. And clearly, the point is that if it's a compression wave, yes, there is no on-off. There's no traveling through the neutral. There is either stuff, no stuff, stuff, no stuff. But that can also be argued that the principle of there being a capacity for there to be tension in a medium, then you have to concede that the tension can have a momentum, a direction. And so it always passes through a neutral point. Anything oscillating will travel through a neutral, but it's not neutral. It's heading somewhere. Damn, that should have worked. Should have, but it didn't.
There. But then somehow it comes
that works.
Back from the light, from the dead, and it goes back to a maximum, and then goes back to 0. There's no way they could possibly regenerate from each other when they hit 0. So I'm saying that entire picture is just on blackboards in your head.
I think what you're saying is you don't understand it, and so therefore it's wrong.
No, it can't be understood as logical inconsistency that makes
I understand it. You just don't seem to be.
So what a stupid argument. Okay, you just don't understand it, so therefore it's wrong. Yeah, I don't understand Muhammad. I don't understand their God. I don't understand voodoo. I don't understand lots of stuff that just doesn't make any sense. Silly nonsense. I'm not allowed to say, where's your evidence? Yeah. You claimed you had it. Why don't you show me it? Marconi is not evidence that there's a magnetic and an electric field.
Able to, so I don't really understand, from my perspective, I don't understand why should I accept something that I understand is wrong because you say you don't understand it. I don't really see that.
If you were to look at what you think you understand,
anyway,
you'd find out that you don't understand.
I think we've reached the crux of the matter, okay? And I don't really see there's much point in discussing it further as far as I'm concerned.
So this is the same thing he did when I was in the room. I don't want to talk about it. I don't want to talk about it. So what? Fuck off then. Who the fuck are you? I mean, he's such a fucking Nazi. He's such a dictator. I will tell you when I'm disinterested, and therefore you should pay attention because I'm disinterested. What an asshole.
All right, well, let's go on to Markelli has a question.
Hello. Hello.
Hello, go ahead.
Yeah, can you hear me?
I can.
This was really interesting. Okay, so you're probably not going to hear this very well because he's like on his phone. But this is the Dowdy guy, okay, the NASA guy. And, but he's sort of off the subject too. But it was interesting that he called in.
Hear you.
Yeah, let me make Franklin, your paper seems to be well written. And the first diagram you have in this paper, you have a chain of waves there where the electromagnetic wave and the magnetic component of that are right angles to each other, and they move at right angles. That is what the experiments have understood for almost a past century. And what you have in your paper.
So he's basically making a defense of this two-wave thingy also, but that's his bad.
Well, basically, this paper seems to be well written.
So he's saying it's well written, but your hypothesis is something.
Hypothesis seems to differentiate from what you have written in this paper. the thing here is, I believe that is misunderstood in your hypothesis, but let me say that to you again. And I'm Ed Dowd, just in case some of you guys may not know me. And I have the website, extinctionship.com. Go to my
Simbin.com. I couldn't tell what he said, so unfortunately I can't. I'd like to see his website. I guess I could look it up on the online. I should be able to find it.
Website, extinctionship.com. And I place a lot of my papers on that and my presentations that I've done. And again, look at the very familiar with some of the stuff that I've done. But let me say that when you look at a wave, electromagnetic wave array, what they call RAY array, that ray is not like a chain, like a very long chain that you stand from one tree to another tree, or a chain that's a mile long, for example. That's not what this is all about. I believe what happens is you have what is known as wave packets.
So again, Franklin Hu used the word wave packet. So he's saying, well, what you have is wave packets. Well, Franklin used the word wave packet. And I would say wave packet is just gibberish. What do you mean? How? Show me. Wave packet. Going two ways. No less. In two different fields, packeting. Show me. Take some little green soldiers, and show me what the wave packet of soldiers looks like.
Because packets of waves, some people may want to call them photons, but some people have problems with photons. I have a problem with photons because photons have been defined over the years. Now, some people have a definition of what a photon is. A wave packet is easier to explain.
No, it isn't easy to explain. So he says wave packet is easy to explain, photon's hard. No, photon's easy, wave packet is nonsense.
What happens is that when an atomic system emits what is known as a wave packet, that is a quantum that is being released.
Okay, a wave packet is a quantum, so that can be understood. Yes, it's a thing moving the speed of light, a discrete amount of energy moving the speed of light. Now the question is that a frequency doing that also? So now we know there has to be more of them.
Actually, that the atomic system actually shoots out a wave packet, and it is quantized, right? It is quantum energy. And the higher the frequency, the higher the energy, the lower the frequency.
So he says the higher the frequency, the higher the energy, lower the frequency, lower the energy. So again, it doesn't have anything to do with reality. Clearly, radio waves, tremendous amount of voltage has to go in to create the durable wave. So it's a lot of, plenty of energy. It's just not at the right frequency. And again, you can sort of understand there's a certain cheat built into frequency. If I make the frequency longer, it means in the same amount of time at the speed of light, there's only a certain number of quanta I could get in to that volume. And if I have them closer together, I can get more in that volume. It doesn't mean I will be sending more. It just means that I can send more. So you can increase amplitude if you have a higher frequency, but you can get more volume in the same amount of space. But it doesn't mean that the individual quanta have any more power.
The smaller the energy is. Now, electromagnetic waves like broadcast stations and kilohertz but even low frequency, which the popular that may be used to communicate with the ships and submarines and so forth. You can build a very large antenna, a very valve antenna, and you can shoot a long wave to the moon. And it could be received on the moon if you get better noise. If you have enough energy, you can do that. Electromagnetic waves
yeah, exactly. Enough energy. The antenna, having a long antenna just gives you more space to throw the density out of. So you have a more volume that you can create. A short antenna can only produce so much. And it's going to, in a sense, be interfering with itself too much. So a longer antenna, better. Even for weak signals, you're better off with a big antenna than a small antenna for producing the radiation. But you can receive it with a small antenna. You're just better off with a big one again, because you're going to collect more photons, obviously. There's no point where a bigger antenna doesn't do you any good. It always improves your signal.
Electromagnetic waves, they go from microwaves, to gamma rays, even the higher flight frequencies. They get all kinds of electromagnetic waves out of deep space. And what happens is that when you look at what is known as a rate of waves, like coming from
I suppose a really big antenna would be aground. So you get too big, then the electricity is you're never going to be able to detect the signal because you're collecting way too much noise. So you're collecting so much stuff that you're not going to be able to get your signal out of the noise.
What is known as the neutron pulsar stars, for example. Some of these pulsars are sending out very sharp energy, so sharp and so precise. Even the atomic clocks on Earth have difficulty taking pace with these things to find out how accurate they are because it's so sharp. We can position our
again, they're so sharp because they're rotating stars. So obviously the on-off signal is being created by the rotation, and the photons are still much. Obviously, the photons themselves either get here or don't get here. The on-off switch is different than the photons. The photons are always going to be more discrete, finer than the switch turning them on and off or blocking them. You can't create an obstacle that moves faster than the photons are being emitted.
Relative motion of Earth, and even our laboratory does this into some of these systems. Electromagnetic waves are electromagnetic waves, and they're all electromagnetic waves as far as you can see. And that very first diagram you have in your paper there, where you have the blue wave, that is electric wave that is in the what is that? You have the X and Y direction, right? The blue wave is in the X direction, and the red wave is in the Y direction, and they are like angled to one another. And that's a very long, but this is what the experimenters understand. How that is.
This is what the experimenters understand. So he's saying the stupid wave thingy is somehow what experiments understand. No, there's no experiments. It's what the theoretical assholes have devised, but it has nothing to do with experiments. There's no experiments demonstrating two fields.
That's a different thing.
No, I would claim that the experimenters have found no such thing. This is all theoretical physics.
So, yes, he made the same point I just made. That's just a bogus argument that experimentalists are sitting there thinking about photons going in two directions when experimentalists is just thinking, I don't want to get electrocuted.
Let me finish that. I'm not disagreeing with you with your hypothesis is difficult for me to understand. But the experimenters, when they go in the laboratory and you teach the students that the magnetic component of that and the electric component of these waves are right angle to one another, and they move and the direction of motion is.
So he's just repeating what Franklin already knows, and what Franklin is saying, I can't possibly make that make any sense. I don't see any reason why I should believe that mush. It's a fairy story.
Also going from in the Z direction, that's the motion, right?
And the experimentalists have never actually found that.
Let me finish.
Yeah, let you finish doing what? Telling him what he already knows, which is, okay, you have a dopey theory, but you don't have any evidence of it, so what's the point? Go ahead and tell me what I already know. Oh, I already know that's your dopey theory. Where's your evidence that that's the truth?
Yeah, but when you design an experimental apparatus, the way you can detect, I can detect only the magnetic component of that wave, and I can also detect only the electric component of that wave.
So he's saying that you can. They have experiments where they can detect only the electric, or they can detect only the magnetic. And again, what experiments? And that only has to do with separating dipoles. So again, yes, if you separate the charges of the dipole, then you can do that, but you're not going to do that with a photon. So there's not going to be any evidence. You have evidence that photons can be in some way appreciated as just magnetic events or appreciated as just an electric event. There's no way you're going to dissect a photon into an electric event or a magnetic event without having them hit an electron, without destroying the photon, without converting it.
The electric component of that wave. I've done that in Germany when I did this magnetic resonance experiment, and I had what is called my right angular polarization or left angular polarization. All these instruments are designed that way. The easiest way to explain it is when you have it in the diagram.
So he says he did some sort of experiments in Europe. I think Franklin's going to ask him what the hell's the experiment, because I haven't seen it.
Yeah, I don't disagree with that diagram. And your paper is one thing, and what your hypothesis is going to say something different. And that's where I disagree with you. So you're looking at long waves from distant stars, and these pulsars have been going for millions of years, and they're sending out long waves going in practically all directions, but it's going in a straight line.
Yes, it's going in a straight line. The wave is going in a straight line. It's doing this in a straight line. Doesn't make any sense. So the interesting thing about this Dowdy guy, so he basically points out how the lensing evidence is kind of fraudulent in the sense that there's no lensing where it should be. That is, outside of the sun's corona, you don't have any lensing. The sun's lamb, the noisy part around the sun, that they haven't found any. And there should be there by Einstein's change in the math. So by Einstein saying photons are twice as sensitive to gravity than electrons, for example, that they should be bent at these further locations, distances from the sun, and there's no evidence that ever happens. And the only place they do get disturbed seems to be when they're flying through a bunch of crap. No big surprise there. That's called scatter.
Straight line as far as we can tell. And it's coming to our telescope. And this is what I said. So I just want to make that point clear. Go to my paper and you can see I talked about this same principle, and I talked about it. And I'm going to click off here now and listen to your comments. Okay? Thank you very much.
Okay, so first of all, I want to make it absolutely crystal clear that my hypothesis that the EM wave travels as a compression wave exactly as sound, and that this picture you see here of the electromagnetic wave having independent rising and falling magnetic and electric fields is a complete fantasy, okay?
Exactly right, and that I completely agree. There's just no real reason, real one, no piece of evidence, no startling fact that makes that diagram true. And the only way this diagram makes any sense is to use this Maxwellian invented notion that we are going to create these separate fields that move exactly the same speed and give them these separate designations, even though they're clearly made of the same thing. The B field is not a separate field. The B field is a positive and negative field, a dipole field, and the E field is a monopole field. Duh!
So everything in my paper, I believe, is consistent with that hypothesis, okay? Now, most of what you said, Joey, I completely agree with, that light can be generated at different amplitudes, it travels in a straight line, and a lot of that is what I explain in my paper. I mean, these are things that people know about, all right? There's no controversy over how those things happen. The controversy that this...
Yeah, there's no controversy over the evidence, so let's just get to the evidence. So if they want to have a controversy, then just point out something that proves this crap. And the best the Harry guy could do, is say Marconi. And Marconi certainly didn't prove there's two fields being disturbed.
This particular paper addresses is how this thing actually propagates. Now, you have claimed, and this is an interesting claim, I would challenge you that you said you have actually measured the rising and falling, say, magnetic field. But I don't think you have, because you said you measured the polarization, okay? That's different, okay? Measuring the polarization has nothing to do with measuring the individual rising and falling fields. As I explained to Harry,
especially when the two fields are rising at the same time. That makes it a little bit inconvenient to say that polarization makes any sense. And again, I'm just saying, what, the electric field gets through, but the magnetic field doesn't. The magnetic field's not affected, only the electric field's being measured. I mean, it just doesn't make any sense.
The only experiment I would accept is if you have an independent, like you said, a string of independent magnetic field detectors, and then on one end of your experiment, you send, like, a fairly low frequency EM waves through that box, and you show me that along the detector line, you can say there's one that says maximum, there's one that's going down, there's one that says minimum, one that goes up, and you would predict experimentally that if EM waves actually travel this way, that you can create a standing wave in there. That as it travels, that you can see this time there.
The standing wave, so you're going to have to create a photon that was reflecting in the same location or something then, so I don't know if they can do that. I don't know. There could be experiments. I'm just saying that obviously they don't have any, so they haven't done any. But that's the whole point here. They won't concede that they don't have any experimental evidence. They don't concede that the evidence for this pattern is incredibly weak, that there is no, the experimental evidence is insanely weak, and the theoretical evidence is thin. So, they won't even concede that, yeah, this is just something we made up that, we can sort of make it work, but it's not necessarily the right answer at all.
Magnetic field, not polarization. If you're measuring polarization, you're cheating. And you're making another interpretation upon interpretation.
Okay,
so
one more comment. What the words that you're saying is coming out of your mouth? What you want to say is the magnetic component of an electromagnetic wave, or the electric component of an electromagnetic wave. That's what.
Why would he say something he doesn't believe exists? So why would he say electric component and magnetic component? He did sort of demonstrate. Just show me one of them. Show me you measuring one of those components. Show us an experiment that in some way indicates one of those things is happening or exists.
I think you're getting confused here. The wave doesn't actually look like that. If you could see that wave propagate into space, you could actually see it. But there are instruments. I can tune my instrument in Germany when I was working in the laboratory in Germany.
He can tune his instrument. It's not great.
I can detect only the magnetic component of the electromagnetic wave, and I get so much energy from it, right? And I can detect also the electric component of the electromagnetic wave. You can tune the instrument.
So he says he can tune an instrument to do this, and obviously I don't think there's any such experiment. You can crash photons into electrons. That's what you can do. You can't do anything else.
And you have to rotate it 90 degrees in order to look at the other component. You have to actually physically rotate this thing about the z-axis, right? And you can see one to the other. And it's a white circular polarized wave, and that thing is actually turning, right? It's actually spinning. You show a diagram like that. That's real. That's in the laboratory. You can see that. You're doing that.
Again, so it doesn't have anything. What he's saying is that he can use a polarizing filter to detect. He's not doing any of that. It's not proving the existence of these stupid fields.
Okay, that's very interesting. That's very interesting. If that was true, that would prove me wrong. But can you give me what's the name of the experiment I should look for?
That the right angular circular polarized instrument is in all laboratories. It's in every physics department in the United States of America. You can go in any physics department.
Right angle polarizer.
And the students, good graduate students can show you that.
Just tell me, what can I search for on Google to find this experiment? As few words as possible.
Go to right circular and left circular polarized light. Go.
Left circular and right circular polarized light. So Franklin already described circular polarization as nonsense. So, whatever.
So go on Google, and you can find it on Google and on YouTube, right? And
no, I during my research for this paper, I extensively researched circular polarization, as it was one of the few things that I was not able to explain. But during my investigation of that, I did not find any evidence of what you speak, which is an instrument that can detect either the magnetic or the electric field. Circular polarization has to do with creating, like I said, I have a circular polarizer I demonstrated here today. This is a quarter wave plate. And I have regular polarizing materials, and I demonstrated what a quarter wave plate does, which is to flip the plane of polarization by 90 degrees. Experimentally, that's it.
Again, it's not a quarter wave anything. It's just the lines going at a 45-degree angle. So let's, they have these, they give something a jargon word and call it something, and it's just taking jail bars that are going this way, you just move them this way. I mean, that's hell.
There is a crystal that you can put on a plate and you can squeeze.
So there's a crystal you can put on a plate and you can squeeze it. So here we have another story.
Crystal, you can put pressure on it, mechanical pressure on that thing, and you can cause that crystal to be softened, just deformed a little bit, and you can cause that wave to slow down and allow the z-axis to spin. That happens.
You can cause the wave to slow down. So again, it's just more more statements as if we actually, or somebody thinks that the light actually slows down when it's going through a transmission medium. The crystal, the light doesn't fly through nothing. It's going through something. It's banging into stuff to be transmitted through the material. You can make glass really, really thick and the light still gets through it. Do people really think it just misses all the atoms and that's why it goes through, is because it misses everything? No, it's hitting lots of stuff. It's just when it hits it, the energy, it keeps its angular momentum. It retains its direction.
That shows you that there's something going on there in the real world, right?
Yeah, it's changing the plane of polarization. That's what this quarter wave thing does. But I'm still looking, I'd be very interested in finding that experiment that you says that rotates. What's the name of that mechanism that rotates?
It may be rotating in a sense when you take the hypothesis of the wave. When we understand the hypothesis of the wave, looking at it in 3 dimensions, right? The x and y being the wave component, and the z direction being the direction of it. How you explain it is a...
And so he says the z component is the direction of it. When you have x, y, and z. So obviously we already know that it has the momentum in one direction at the speed of light. But again, this idea that we're functioning in 2 fields, that's your statement. Well, where's the evidence that either one of these things exists as any kind of field that always exists in some way? Where's your evidence that it isn't stuff flying somewhere?
So hypothesis again. That's where I have a difficulty. I think you said just a minute ago, you sound like you're very reasonable with the way you said it a minute ago. I agree with that. But then again, you say something else.
Well, the only things that you could possibly be recovering is, say, the vector direction of the ray, really, in my hypothesis. because there is
When
no
you say ray,
recoverable.
what do you mean? What do you mean by ray? When you say ray, R-A-Y, what do you mean by ray?
I mean a ray
Change?
that
Are you letting
that the EM wave propagates like this pencil I'm holding. That it is still a wave compression wave phenomenon. This pencil can contain like 10 individual wavelets in there, but it may.
Yeah. So there's 10 individual wavelets. So there's 10 individual pencils inside the pencil. So you can't see why this is just a broken analogy. 1 minute the photon's a pencil, the next minute the pencil's a ray. You can't have it both ways.
Maintains its very thin pencil-like, and that it travels through space maintains its structural, its spatial integrity.
Now, sound needs a medium in which to propagate. Electromagnetic waves does not need a medium. You can have an ideal vacuum, a really high vacuum, and then electromagnetic waves fine. Right?
No, that's
yeah. Again, so he's saying now you can have a high vacuum electromagnetic wave is fine. Waving in what then? What is it waving in? What is this field? Okay, so again, it's just I don't know why people are so glued to this stupid medium crap.
Logical contradiction.
A series of packets. A series of packets. We're not talking about a series of packets. A whole bunch of packets. A lot of, right? You can't even count. There's so many in it, right? It seems like a change, but it's not really a change, right? So that's just the way I go. Okay, I'm gonna listen now. Okay, guys. Thank you.
Well, see, I would point out that to have a wave but no medium is a logical inconsistency. Literally impossible. It's like saying black is white. To say that,
yes, exactly. So if you're going to say there's a medium, then take responsibility for it and explain how you have any evidence of it. Because you really should. Because for it to function the way they want it to function, it has to have a stickiness. To bend waves, to do all this stuff, it has to have a stickiness. The stuff has to be, it's like a trampoline. The little bits have to be tied to each other. There has to be tension in the bits for you to compress it and for it to deform in this rounding shape to create your round waves. There has to be tension in their medium then. And then you have to explain how this medium with tension allows planets and other stuff to fly through it without any problem. It's stupid.
Electromagnetic waves can travel, can have, we can recover the amplitude of the electromagnetic wave, and we can convert it to sound. In fact, I can take 60 hertz radio wave, convert it into sound, and which means it has.
No, you can't. You can't listen to a radio wave in the atmosphere, I don't think, but you could certainly, the inverse is possible, that you can have vibrations that you can create radio wave, that is photons, as you're emitting, as you're moving the atmosphere, as you're pushing the atoms, you're also emitting photons. So you can have things that create sound that are also creating radio waves, photons. But not vice versa, I don't think.
It has exactly the same properties, but we know in order to be a wave, there has to be something which has to be varying. That varying thing has to be a medium. So to say electromagnetic wave travels without a medium is it's a logical inconsistency. This is what I call...
right. Waves can't travel without mediums, but particles can.
In science, it's doublethink. That in one way, we know that a wave requires a medium, but yet we perfectly accept the fact that the electromagnetic wave doesn't have a medium. That is doublethink, right? The only reason why you believe that is because it's been pounded in your head, even though it's an obvious contradiction to what we would normally associate with a wave. All
right, so we'll end here, and maybe I'll play the end someday, or maybe I won't. We'll see how I decide to do. Because I don't even think I've even heard much past here. But yes, it's time to go. Yes, I'm tired. See if it's still recording, hopefully. Yeah, sorry. It's like a 2-hour one. Yeah, almost 2 hours. So anyway, till the next time and such. Yes. Really important subject, though. I mean, it's so elemental. If we can't get this, you can't get these fundamental things: electricity, magnetism, photons. Electrons, atoms. This is physics there, and that little ball is so much of it. Getting that right, and I would argue they got all of it wrong.